The Ford GPA, America's amphibious disaster. Imagine spending $250 million to build nearly 13,000 vehicles that soldiers actively refuse to use. The Ford GPA, America's amphibious Jeep, a machine designed to drive straight into rivers and across oceans. On paper, it was brilliant. In practice, it killed more careers than enemies. It sank in calm water. It capsized in moderate waves. It drowned its own crew in conditions where rowboats thrived. The United States Army built 12,778 of them, and by the war's end, commanders were using them as scrap metal and ballast. They were dumped into the ocean, buried in fields, abandoned on distant islands. But here's what the official reports never mention. One fatal design flaw made the GPA not just ineffective, but genuinely dangerous. A flaw so obvious that we'll reveal it shortly. A flaw that engineers should have caught before the first prototype ever touched water. This is the story of America's most expensive floating failure. 1941. The United States isn't yet at war, but it's watching. In Europe, Germany has demonstrated something remarkable. The Schwimmwagen, an amphibious vehicle that crosses rivers without bridges, without boats, without stopping. It drives into water and keeps moving. For an army planning to invade continents, this is revolution. Rivers are no longer barriers. Coastlines are no longer fortress walls. American military planners see the future clearly. The coming war will demand beach landings, island hopping, river crossings under fire. The standard Jeep, the Willys MB, is already proving itself as the most versatile vehicle ever built. Tough, simple, reliable. But it stops at the water's edge. So the order goes out, build an amphibious Jeep. Combine the Willys' legendary dependability with boat-like capability. Let infantry drive from ship to shore without specialized landing craft. Let reconnaissance units cross rivers without engineers. Let supply columns ford streams without delay. Ford Motor Company gets the contract. They call it the GPA, government. P for 80-inch wheelbase. A for amphibian. The specifications sound impressive. 4-wheel drive on land, propeller driven in water, sealed hull, watertight compartments, a Jeep that swims. The engineers start with the Willys Jeep chassis. They modify it, shorten it. The GPA ends up 64 inches wide and 14 feet 7 inches long, smaller than a standard Jeep. This should be the first warning sign. Boats need size for stability, but the design pushes forward. The hull is stamped steel, welded seams, a pointed bow like a boat. The entire undercarriage is sealed to create buoyancy. In theory, every surface contributes to flotation. The engineers add a 3-bladed propeller at the rear, driven by the main engine through a power takeoff. On land, the driver engages 4-wheel drive. In water, the driver switches to the propeller. 1 engine, 2 modes. Elegant simplicity. The engine is a 4-cylinder flathead, 54 horsepower, the same engine family that powers standard Jeeps. On roads, the GPA reaches 55 miles per hour. In water, the propeller pushes it to 5.5 miles per hour. Swimming speed. Not fast, but steady. Or so the testing suggests. Weight becomes the critical specification. The GPA weighs 3,450 pounds empty. A standard Jeep weighs just 2,450 pounds. The GPA is 1,000 pounds heavier because of the sealed hull, the reinforced chassis, the propeller assembly, the additional structural steel. This extra weight means less cargo capacity. The GPA can carry a 1/4 ton, half what a regular Jeep manages. For every pound of flotation equipment, the military loses a pound of ammunition or supplies or wounded soldiers. Ford builds the first prototypes in 1942. The initial tests are promising. The GPA drives into calm lakes. It floats. It moves under propeller power. It drives back onto land. Success. Production begins immediately. 12,778 units. Ford's factories in Michigan retool from civilian cars to amphibious war machines. Assembly lines stretch across vast factory floors. Steel arrives. Engines arrive. Propellers arrive. Workers weld hulls. Install drivetrains. Bolt on axles. Paint them olive drab. The cost is staggering. Each GPA costs roughly $2,000 in 1943 money, nearly 20 times what an infantryman earns in a month. Multiply that by 12,778 units. The program consumes resources that could build tanks, aircraft, artillery. But then the GPAs reach actual military units, and the complaints begin immediately. Soldiers nickname it the seep. Some claim it means sea jeep. Others insist it means it seeps water. Both are accurate. The GPA leaks. Not occasionally, constantly. The welded seams, supposedly watertight, let water through. Every wave, every ripple. Crews bail water while trying to navigate. The bilge pump runs continuously, and it's still not enough. Then comes the stability problem. The GPA sits low in the water, very low. The freeboard, the distance from waterline to deck edge, measures less than 1 foot. In perfectly calm conditions, this is manageable. But war doesn't happen in calm conditions. Even modest waves slop over the sides. The weight of that water makes the vehicle sit even lower. More water comes in. The GPA starts sinking under its own accumulated leakage. Before we go on, if forgotten and impossible war machines fascinate you, subscribe to Forgotten War Relics and hit the bell so you never miss one. And here's that fatal flaw we promised. The GPA's center of gravity is too high. The sealed hull creates flotation, yes. But the engine, the transmission, the heavy drivetrain components, they all sit high in the chassis. Top heavy. In water, this creates catastrophic instability. The vehicle wallows. It rolls in moderate chop. Crews discover that turning too sharply in water can capsize the entire machine. One hard right turn, the GPA tips, water floods in. It goes down in seconds. The designers chose vehicle performance over naval architecture. They built a Jeep that floats, not a boat that drives. The first combat deployments reveal the scope of the disaster. Sicily, July 1943. Operation Husky. American forces plan amphibious assaults across multiple beaches. The GPA will deliver troops and supplies from ship to shore, then transition to land operations. On paper, revolutionary. In practice, catastrophic. The vehicles launch from landing craft in rough Mediterranean seas. Waves run 3 to 4 feet, not a storm, standard conditions. The GPAs immediately take on water. Crews bail frantically. Some vehicles make it 50 yards, others less. The low freeboard means every wave washes over the deck. The bilge pumps scream. The water keeps rising. Then the capsizing starts. A GPA turns to avoid debris. The shift in weight combines with the high center of gravity. The vehicle tips past the point of recovery. Water rushes into the open crew compartment. 4 men bail out. The GPA rolls completely over and sinks in under 30 seconds. Then another goes, and another. Commanders watch their amphibious capability literally sink before reaching the beach. Those that do make it to shore arrive half-flooded, crews exhausted from bailing, equipment soaked and useless. The supposed advantage, the ability to drive immediately inland, means nothing when your vehicle barely survived the water crossing. The numbers tell the story. The Army receives reports of 30% losses during amphibious operations, not from enemy fire, from the water itself. One unit loses 8 GPAs out of 12 in a single landing. Another reports every vehicle taking on dangerous amounts of water, with 3 total losses. The after-action reports use words like unseaworthy, dangerous, and unsuitable for combat operations. Commanders stop using them for assault waves. Too unreliable, too many losses. The GPA gets relegated to calm water crossings, rivers, protected harbors, situations where a standard boat would work better anyway. The entire amphibious assault capability, the reason the vehicle exists, becomes operationally irrelevant. The Soviet Union receives thousands through Lend-Lease. They report similar problems but find one niche use: river crossings during rapid advances, not assaults, not opposed landings. Simple crossings of calm rivers where the GPA can make multiple trips. Even then, Soviet crews prefer boats, actual boats, the ones designed for water. Some GPAs serve in the Pacific. Same story. The Marine Corps tries them, rejects them almost immediately. They have the DUKW, the larger 6-wheeled amphibious truck. It actually works. Higher sides, better stability, proper naval architecture. The DUKW becomes legendary. The GPA becomes a footnote. By late 1943, production stops. 12,778 vehicles built. Most never see combat. Many sit in depots, unused. Others get converted for non-amphibious roles, the water capability stripped away or ignored. The ones that do deploy spend more time being repaired than operating. The fatal flaw was baked in from the start. The designers wanted a Jeep that could swim. They needed a boat that could drive. Naval architects understand the difference. The GPA's creators did not. They prioritized ground mobility and tried to add buoyancy as an afterthought. You cannot cheat physics. You cannot make a top-heavy, low-sided vehicle stable in open water. The GPA proved this lesson 12,000 times over. After the war, most GPAs get scrapped. The ones that survive become curiosities. Collectors restore them for shows. Museums display them as interesting failures. Nobody tries to replicate the design. The concept itself gets abandoned for decades. Modern amphibious vehicles learned from the GPA's failure. They start with naval architecture, then add ground mobility, low center of gravity, high freeboard, proper stability calculations. The Marine Corps' current amphibious combat vehicle weighs 35 tons and sits 3 feet above the waterline. It doesn't pretend to be a Jeep. It's a boat first, a vehicle second. The GPA represents a fundamental misunderstanding of design priorities. It tried to be 2 things and failed at both. Too heavy and awkward for effective land use. Too unstable and leaky for water operations. The worst of both worlds wrapped in a 12,000 unit production run. 70 personnel carriers. That's what the initial requirement called for. The Army ended up with nearly 13,000 vehicles that couldn't safely carry personnel across water. A bureaucratic momentum carried a flawed design from prototype to mass production, while the fundamental problems remained unsolved. The forgotten amphibious Jeep, built in thousands, used in dozens, remembered by almost no one. If you enjoyed this, subscribe to Forgotten War Relics for more of the strangest machines history forgot.